Now, I've published a new section there on Moodle, which is here. So the title is bundling, and within that, there's a subtopic called code splitting. This topic now is very much aligned with the web app dev module. It's really part of something that you've been doing in the background in web app dev. The reason I'm bringing it into this module is because bundling is really part of the CI/CD pipeline. It's a very important part. It's probably the first step. Well, okay, the first step in the CI/CD pipeline may be to install the node modules. But the very next step is what I was referring to generically as building your application. Building really means converting your source code into a form that can be deployed onto the cloud. Now, the equivalent of building in the context of a front-end web app is what's termed bundling. So that's the association. So I'm just going to walk my way through the slides. I don't think I'll get through all of them today, and that's fine. Now, the main heading here is Webpack. So Webpack is just a tool, and it is a tool that, as I've kind of already alluded to there, you've actually been using all along, unbeknownst to you. And what is Webpack? Well, as I've already indicated, it's a build tool for building, and specifically it's for building front-end web applications. So that's the link with CI/CD. Now, this Webpack tool comes as part of the Create React App wrapper tool that you use in web app dev. You don't have to use Create React App, but it's by far and away, well, although its popularity is slightly decreasing now, but for a number of years, it's by far and away the best kind of starting point when you're developing a React app. And we know what the Create React App tool does for you. So so it's really a combination of a number of lower level tools, one of which is this Webpack tool. And so on the screenshot, what I'm saying is, you know, when you run the npm run build command from the command line, really what's happening there is you're kicking off the Webpack tool. And we know now from our previous topic, the CI/CD topic, that this command actually generates this build folder in your React app. And that build folder contains within it a JavaScript file. And the JavaScript file contains all of your source code bundled into one JavaScript file, hence the term bundling. So the command generates this folder with lots of files within it, but of particular interest to us is the JavaScript file, which contains all of our source code. And really, if you point any web server at this folder, then it will serve up your React app. And we know that from both what I've covered previously and what you've covered in the web app dev. So I'm saying essentially, if we run the go live server and point it at this folder, then it'll serve our React app, our movies app. But it's a static version of our movies app. We don't have that live reloading that we experience when we're in development mode. So what exactly does Webpack do for us? And okay, so I'm saying it's a module bundler. A module here is essentially a JavaScript file, although we'll see in a second that, or a little bit later on, that Webpack also understands CSS modules. So if we had in our movies app, if we were writing our own custom CSS, then presumably we would split that CSS up into a number of files. Each of those files is a module in the context of our overall web app. And Webpack understands CSS bundles or CSS modules as well. Also, if we had even different forms of CSS, so if we had a SAS file or a LESS file, Webpack understands all those because they're all modules within an overall front-end web app. And even static images, if they were part of our web app, or if we had custom font files, all of those are different types of modules that Webpack understands, and it bundles them all together for us. So essentially what it does is, I'm saying here, is it analyzes the dependencies of your web app, the dependencies between the various modules. And by the way, I'm also including the node modules, the kind of third-party ones, because we import lots of third-party modules into our custom code, you know, the Material UI stuff, as well as the React and React Router and React DOM. So it essentially analyzes the dependencies between the various modules that make up your web app. And from those dependency relationships, it kind of computes an overall packaged version of your web app. And that packaged version is, if I go back to the previous slide, is what will be contained inside here. So what are modules? Well, JavaScript files, CSS files, font files, image files, as I said. And it understands, you know, if you've got ES6 JavaScript, it understands that. It understands the kind of import statements that appear in ES6 modules. It also understands the older form of importing, which is using the require statement. I don't think you've actually needed to use it at all in your web app dev module, but previously, like sort of pre-ES6, the way we imported one file into another is using this require statement. And the require statement was part of what was referred to as the common JS modular system. But now we're effectively using ES6 modules. But Webpack understands both of them. So it's, you know, it understands legacy code as well. There was also another form called AMD, which you don't hear about anymore. So bundling then is where Webpack generates a static version of your web app, and it does that by analyzing the dependency relationships between the various modules that make up your application. Originally, really, Webpack was designed for very large web apps, but it's being used for smaller ones now. This is a kind of a visualization of what I'm trying to get across here. So on the left, we have our source code, supposedly. And so we've got various files. Let's just assume, for simplicity's sake, the only types of modules we have are JavaScript modules. So let's say this looks like the index.js file at the very top of our module hierarchy. So this would be the equivalent of the src/index.js file. It has imports, so it seems to be importing this one and this one. Those JavaScript modules are importing other files. And so what Webpack does is it starts here and it navigates through the various dependency relationships. So it has a full understanding of the dependency model of your web application. And from all of that, it generates one single bundle, which contains all of our code. Now, this will contain some Webpack specific wrapper code as well. Not simply a case of just taking all of this and packaging it into a single file. It adds some additional code as well. More generically, let's supposing on the left here, we have a mixture of different types of modules. So for example, it looks like we have, I don't know if you've ever heard of CoffeeScript or not. CoffeeScript is a form of JavaScript. Is that right? Well, CoffeeScript is a language that can be converted into JavaScript. So it's actually a kind of a functional programming language that was reasonably popular maybe about 5 or 6 years ago, not as popular today. So anyway, let's supposing for whatever reason I decided to write some of my web app in CoffeeScript. I've also got some CSS files. Where have I got? Do I have any? Yeah, CSS file here. By the way, I'm assuming you know that you can import a CSS file directly into a JavaScript file. You would have done it at the very beginning of the web app dev module, but you can anyway. And it looks like we have a less file as well. Less is another form, a kind of a more abstract form of CSS, or a higher level form of CSS. So the point, and we've got an image file, it seems like here as well. So our application, our source code, if you like, is a mixture of different types of source code files, but there is, again, a dependency hierarchy relationship. Webpack analyzes them. And in this case, because there are different types of source code that make up our application, it creates a number of bundles. It creates one bundle that contains all of the CSS, another bundle that contains our images, and you can as well control how many JavaScript bundles should be generated. We'll see how you do that later on. So it looks like it's created 2 bundles of our JavaScript code. So that's what Webpack does kind of visually. Analyzes dependency relationships and generates these bundle files on the right-hand side. Digging a little bit deeper into Create React App. So in the screenshot here, I'm showing you in the package.json. If you look at it yourselves later, you see that, well, what am I saying here now? I'm showing you, yeah, there is in the script section of the package.json, there is one script called build. And when you run the build command from the command line, npm run build, what you're actually running is a script called React Scripts. So React Scripts is another third-party library that comes with Create React App, or that Create React App kind of includes within it. And it's really this React Scripts. If we dug into that, it's this React Scripts third-party module that contains Webpack within it. So that's kind of the hierarchy that's going on there from a tools point of view. The Create React App tool uses the React Scripts package, and the React Scripts package, it uses Webpack, and it also understands React, of course, but React comes as a separate module, as we know. And so when you run the npm run build command, essentially what you're actually doing is you're running the React Scripts command, and the React Scripts command, it generates the build folder. And all I'm showing you down here is, you know, it's in its output, it's showing you the different bundles that it has created. So in this particular example, it looks like it's created a number of bundles. So some of them might be JavaScript bundles, other ones might be CSS bundles. So that's just a slightly deeper look as to what's going on. So we've introduced this new thing called React Scripts, which is part of the Jigsaw, specific to the Create React App tool now, admittedly. And in a little while, I'll show you that within the React Scripts package, that's where you'll see direct evidence of the use of Webpack. So Webpack is kind of what I really want to talk about, even though we don't use it directly, but it's being used indirectly. Before Create React App, that tool came along, we did use Webpack directly when we were developing our React apps. And it's not specific to React now, by the way. Webpack could be used with Angular or any of the other front-end single-page app frameworks. So in terms of Webpack, these are some of the main kind of concepts. So you've got to tell the Webpack tool what is the entry point for your front-end web application. The entry point is essentially the module at the very top of your module hierarchy. Now, in the case of our React apps and the Movies app, that would correspond to the index.js file in the src folder. That is the starting point or the entry point for our Movies app. That's where you've got to tell it where that is. And once you tell it where that is, then it will follow the import statements in the entry point and the import statements in the dependencies as it navigates down through the dependency hierarchy. Also, you've got to tell Webpack what loaders should it use. Now, it's these loaders, they are what take our source code and generate the bundle files. So there are actually a number of loaders. One loader might be responsible for taking ES6 JavaScript and converting it into ES5. By the way, I'm not sure if I mentioned or not, but the bundles that it generates, the JavaScript bundles that it generates will contain ES5 JavaScript. It always has to be ES5 that we send down to browsers just to ensure that older browsers can run our code. So, right, so there will be a loader that is able to convert ES6 and ES7 and ES8 into ES5 JavaScript. There may be, if you're using CoffeeScript in your code, then you'll need a separate loader that will transform CoffeeScript into ES5. If you're using TypeScript, TypeScript is actually very popular now for React developers. If you're writing your React code in TypeScript, then we need a loader that can transform TypeScript into ES5 JavaScript. Similarly, if from the CSS point of view, if your custom CSS is written in Sass, then you will need a loader that converts Sass back to plain old CSS, and so on and so forth. So you need to tell Webpack, somehow you need to configure Webpack with what loaders it needs to use in order to take your source code and convert it into bundles. Also, from a Webpack point of view, it has this notion of plugins. And so, okay, the core function of Webpack is what's performed by these loaders, converting your source code and generating a bundle on the right-hand side of that diagram that I showed you earlier on. But there may be some sort of additional functionality that you want Webpack to perform for you. And this additional functionality is usually implemented in what are referred to as plugins. And there are lots and lots of plugins that have evolved over the years, really, mainly from the open source community, that do lots of different things for us. For example, you might have a plugin that generates the index.html file for you, or you might have a plugin that just carries out some cleanup operation in your build folder before it generates the new production version of your app. And there's lots of other kind of fancy plugins as well. We don't really care much about the plugin side of things. Now, even though I'm telling you about this stuff, you know, we never see these things directly, but I will show you how you can actually see where these things are actually working within your Movies app. So we need to configure Webpack, because Webpack is just a tool. We need to tell it what we want it to do for us. There are different ways that you can configure Webpack. You can do it from the command line. This is, I suppose, if we were using Webpack directly now. You can do it from the command line. You could actually write some JavaScript code which talks to the Webpack tool. So you could configure Webpack programmatically. Number three, you could create a configuration file, give it a specific name, and once Webpack sees that file in your file system, that it knows that's the file I need to use, to work out what the developer wants me to do in terms of creating bundles for them. And it's this configuration file is by far and away the most common way that we configure Webpack for a particular application. The file name conventionally is called this. Okay, so essentially Webpack goes looking for that file, and then once it finds it, it uses it. Now, going back to our Create React app, so in this screenshot, I said previously there that Create React app uses a package called React Scripts, and it's the React Scripts package that manages Webpack for us. And so what I'm showing you in this screenshot is if you go into the Node modules folder in your Movies app, if you just open it up and then scan down through it and look for the module called React Scripts, and that's what I'm showing you here. And if you expand the React Scripts module, lo and behold, you will find a file called webpack.config.js. And that is the Webpack configuration file that Create React app is using for you when you run the npm run build command. Now, on the right here, I'm showing you the contents of that configuration file. You needn't really need to look at it. You don't need to understand it necessarily. It is a JavaScript file, by the way. It's not a JSON file. It is a JavaScript file. But in the early days of React web development, we had to actually kind of write this Webpack configuration file ourselves. Now, okay, it was fairly standard from one project to the next. And if you did scan through this file, then you would see, for example, there would be a section where you explain or point at the entry point for your web application. There would be a section that allows you to configure the various loaders that you need to use, that you want Webpack to use for you. And there would be a section where you configure the various plugins that you want to have used, that you want Webpack to use when you build your application. Okay, so these are the, if I go back to to here, you see evidence of these ideas here appearing in that configuration file. So just maybe take a second to explore that in your own time, and you can actually tell Create React app to take this file and place it into your base folder of your React app. And you would only do that if you actually wanted to do some special configuration, Webpack configuration, that isn't part of the standard configuration. What you see here is the standard configuration, and that is sufficient for 99% of React applications that you might be developing. But if you have a particular edge case, then the approach you would use is you would tell Create React app to essentially take this file and dump it into your main or into your base folder, and now you can edit it in any way that you want to. I wouldn't advise that though. So if we just take if I go over to VS Code, so what you're seeing here is essentially the Movies app. Is it? Let me see. I've got a couple of other React projects. It looks like the Movies app to me. Yeah, it is the Movies app. And I've ran npm run build on it. So I have my build folder here. And if I drill down into it, into the static subfolder, that's where our bundles are put. Now, because we are not writing any custom, well, it's inside here, because we're not writing any custom CSS and we don't have any static images, then the only bundle that Webpack generates for us for this project is a JavaScript bundle, and there it is there. And if I look at this file, you know, it's doesn't look like JavaScript, but believe me, it is JavaScript. See, what Webpack does is it gets rid of any kind of white space in your source code. So there's no kind of indentation and alignment or any of that kind of stuff. But this, if we could, we would find our source code inside here. And the only way I can kind of prove that to you is if I try and do a search for movies, for example. Let's see. You can see here, okay, that does look like something that we have written in our source code. So it's definitely, that's the only way I can kind of, one way of proving to you that our source code is somehow buried inside in this bundle file. But there is other kind of Webpack wrapper code in there as well. Clearly, we can't make any sense of this. So it's this file here that I'm showing you. This is actually what is sent down to the browser. And the browser can execute this. And it's this file that it uses to, you know, display what it displays on the screen for you. Clearly, this file is a much more kind of compact version of your code. You know, there's no indentation alignment, there's no white space. It's all just squashed into one file, and the overall size of that file compared to the cumulative size of the various source code files that make up our application is much smaller. And that's good because it's less bits that have to be sent across the wire from the server to the browser. Okay, so Webpack produced that file for us. And as I've just said, that is the file that is sent down to the browser. But if there is some bug in our code and, you know, the browser generates our code, throws an exception, and we can see evidence of that exception if we open up the developer tools in the console tab in the developer tools. But sort of the problem is that the error will refer to where the error occurred in this file here that I'm showing you. What we really want to know is where is the error in relation to the source code that we have written? Because, you know, we can't make any sense of this file that I'm showing you here. What we really want is to be told by the browser, well, the error was thrown in a particular component file or a particular page file, and whatever the error is. So we want to be told the name of the file, the source code file that relates to the error. Now, how does, and that is the kind of errors that we have seen in the developer tools when our application throws an exception. So how come the browser is able to tell us the particular source code file that is causing the exception, even though the code that it's running is the code that I'm showing you? And the answer is this thing called source maps. So source maps are maps that map a line from a bundle back to a particular line in a particular source code file, essentially. And Webpack generates these map files for us. Now, you know, we could spend a lot of time looking at what the structure of a map file is, but we certainly don't need to do that. And there is never a reason for us to understand the structure of these map files. All we need to be aware of is what their purpose is. So they're generated, and I've kind of explained what the overall objective of these map files is. So, you know, instead of getting an error like this, let's say, from the browser, where what it's referring to here is the name of the bundle file, okay, main.some hash value.chunk.js. That's roughly, well, it's slightly different from the names that I'm showing you there, but you know, here's the name of the bundle file here. The name kind of slightly changed between the version of Webpack that I was using when I took this example here and the names of the bundles today, but that's okay. So instead of getting an error like this, you know, which means nothing to us, what we'd like is to get an error like this in the browser, which we can use. And that's what source maps do for us. What am I showing you on the right? Oh yeah, and so where are these source maps? Well, they're physical files, and you could nearly have guessed it looks like that's it there. Again, you know, there's no point in looking at the contents of that. So that's source maps, and we know what their purpose is, and Webpack generates them for us. You can, so it's generated by Webpack, and so you can tell Webpack via the configuration what type of source maps you want. Turns out that there are different types of source maps. Essentially, the two main types are, do you want your source maps to be separate from the bundles, or do you want them to be contained within the bundle? Now, when you're in development mode, including the source map within the bundle file itself would be fine, you know, but when you're generating a production version of your app, it's best to keep the bundle and the map files separate. But you can configure Webpack as to which approach you want to use, and you can actually tell it to generate one type of map file when you're in development mode, and a different type when you're in when you're producing production level bundles. So we're not really doing very interesting information on that slide there. Just a little bit back on loaders. We know what the overall purpose of these loaders are, is to convert our source code into the form that's contained within the bundle file. And as I've kind of already alluded to, there are loaders that can take any of these kind of modern JavaScript code and convert into ES5, CopyScript convert into ES5, TypeScript. So I've kind of mentioned all that already. There are loaders that, sorry, what am I saying here? Loaders are, oh yeah. So the loaders are associated with particular types of source files. So you've got to tell it which type of source file should a particular loader be concentrating on. In other words, what types of files within the source code should a particular loader be aligned with. And that kind of tells Webpack then, when Webpack is navigating the dependency hierarchy and it comes across a particular file, it essentially looks at the file extension, and based on the file extension, it hands that over to a particular loader to do the transformation before for whatever goes into the bundle. So again, this is something that you would have within your Webpack configuration file. You would have a list of the different file extensions and the particular loader that you want to have associated with a particular file extension. It's part of the Webpack configuration. Loaders are just separate NPM modules, you know, by the way. So they're installed. When you installed, in our case, because we're using Create React App, we install React scripts, but in the React scripts package, it has a package.json file as well. And if you looked inside that, you would see that it contains as its dependencies, as its kind of module dependencies, references to particular loaders packages. Plugins are also implemented. You can then kind of link up plugins with certain loaders. So you can say, I want this plugin to execute after a loader has transformed or before a loader has transformed a particular file. And what the plugin does depends on what the purpose of the plugin is. The key point here anyway is that loaders are linked to particular files based on the file extension within your source code. I've also kind of covered this already. So Webpack isn't just a bundler for JavaScript, it's a bundler for other types of files as well, in particular CSS files. And so not only does Webpack, is it able to navigate a dependency hierarchy within JavaScript files. In other words, it can follow the import statement within JavaScript files. It can also navigate the dependency relationships between, let's say, the various custom CSS files that make up your overall application. And as you may know, this is the import statement that you can use in a CSS file if you want one CSS file to essentially reference another CSS file. And Webpack is able to interpret that statement, and it knows that it's declaring a dependency relationship between two CSS files in your overall application. I'm assuming you know that you can have within a JavaScript file, you can have a reference to a CSS file, so that you use the same kind of JavaScript import statement to do that. But in this case, the import statement would not be referring to another JavaScript file. It would be referring to a CSS file. That doesn't bother Webpack though. It's able to understand that dependency relationship. You can embed images in JavaScript, and it's able to understand that dependency relationship. You can embed fonts, which we haven't used. So, the overall point is it doesn't matter what the source and destination of a dependency relationship is, Webpack is still able to build up its understanding of your module hierarchy within your application. Hence, it's able to produce from what's on the left to what's on the right. What's next? Well, yeah, that's okay. That's kind of covering the same ground. I'm just giving you some sample code. So I'll just move on from that. I'm just checking my watch. Okay. On the plugin side, I'm not too fussed about this. Again, I'm just kind of including it for completeness. Some plugins I'm saying there are built into the Webpack tool itself, and then other plugins are just third-party plugins that you have to install separately. And excuse me, you import them into or you reference them from your Webpack configuration file. Is there anything else of use there? I'm just mentioning one or two here. So this is a plugin that will essentially clean up your build folder at the beginning of each execution of the build task. Okay, it's fairly straightforward. This is a slightly more interesting one. If I go back to VS Code, see, part of the output of the build is an index.html, which is here. Now that index.html is generated by Webpack. And the HTML file has to reference in my case, it needs to reference this JavaScript bundle. Okay. This bundle file is, as we know, produced or generated by Webpack, and the name of the file includes a hash value. I'll talk about that hash value in a little while. Actually, it's actually computed. That hash value is computed from the contents of the bundle itself. But either way, it's just a hash value. So this file name is produced or generated by Webpack, and that file has to be referenced from the index.html. But the Webpack tool, and in particular, the plugin that I mentioned there on the slides, this plugin down here, this plugin here, it's the one that just takes care of that for you. Yeah. So if I scanned across, oops, sorry, no. Oh dear, sorry, just give me one sec. I'll get there eventually. If I go looking for main, let's say, because that's part of the name, then has it found it? There it is there. Okay, so it's a script tag, obviously, you know, but just including that script tag within the index.html, that is just taken care of by a plugin for us. It's a small part of the build process, but it's an important part, obviously. So it's not a loader that would take care of this particular task. It's a plugin that does it. Now, in general, when we want to produce or build a production version of our app, there are certain concerns that we need to take on board. Unfortunately, Webpack does that for us, but you need to be aware of what the concerns are. Number one, the actual bundles themselves need to be as small as they possibly can be. And we've referred to that as minification. And when I showed you the contents of the JavaScript bundle there, then it was indeed minified for us, and Webpack did that for us. Uglification is a slightly, it's kind of a variation on minification. Sometimes people use these two terms to mean the same thing, and there's no problem with that. But technically what uglification is I'm not sure if Webpack actually applies it, but you know, in our source code, we like to use meaningful variable names, for example. But the browser doesn't care about meaningful variable names. So what a bundler might do is, especially if you've got very long variable names, is it will actually change them to something very short, and maybe just a hash, some sort of hash value is generated for the variable name, where the hash would be a much shorter thing now, actually. And that everywhere your long, meaningful variable name appears within your code, it will replace it with this shorter, meaningless variable name. But as long as the variable name is unique that it has generated, then it will suffice from an execution point of view. So that's really and the same would apply to, you know, function names. If we had long function names or class names or method names, you know, it will actually change them to a shorter, meaningless name, but because it's shorter, then we're reducing the overall size, albeit in bits, of our bundle. But the main part, I suppose, is minification. And we saw Webpack does that for us. Caching is an important thing as well in the whole building stroke bundling discussion, and I'll talk about that. And as it turns out, Webpack, in terms of what it outputs is something that supports the whole notion of caching. I'll explain that in a moment. And thirdly, and this would be kind of specific to building in the context of front-end web apps, is this notion of code splitting. And I'll discuss that with you, and that's really what the lab associated with this section will address. The collective term I'm saying for all of these issues or these concerns is this idea, this notion of optimization. We want to optimize the production version of the app, where the optimization is linked to the issue of load time. We want our application, and load time really is the kind of initial time that it takes once the user navigates to our web app, then how long does the user have to wait before they see something appearing on the screen? That's referred to as load time. And one of the main aspects or contributors to load time would be how long does it take the network to download the bundles into the browser. Once they're in the browser, then the load time, the browser, it's an issue of how quickly the browser can execute the bundle, but it's the downloading of the bundles that will influence load time predominantly. And so obviously the smaller the bundles, or ideally if the bundles had been downloaded previously to the browser, then there shouldn't be any need to download it again. Hence, the browser is actually caching the bundles. I'll talk about code splitting in that context a little bit later on. And so Webpack uses plugins to support this these issues up here. So the minification is really carried out by a plugin. It's not the loaders that perform minification. The loaders just do the transformation. But once the transformation would probably include, indentation, alignment, and a lot of white space. But carrying out minification on that then is performed by a plugin. We don't really care which plugin it is, but it is done by a plugin. I've kind of already this screenshot I've already actually mentioned to you, because I showed you the contents of the bundle, and we could indeed see that the bundle had been minified. Now, in relation to caching, so caching is a really important part of the overall kind of internet infrastructure I'm saying here. And lots of the elements that make up your internet network support caching. So CDNs support caching, your internet service providers support caching, the lower level networking devices themselves, the various routers that make up our global network, they support caching, and the web browser supports caching. So can our Webpack tool enable or allow the web browser's caching support to be used for our React app? And the answer is yes, it can. And the way it does it is based on how it names the bundle files themselves. And what it does is it computes a hash value. So once the bundle file has been produced by a combination of the loaders and minification, so we have our actual content now for our bundle file. What Webpack then does is it computes a hash value based on that content, and it uses that hash value as part of the bundle file name. And you saw that in VS Code. So for example, this value here, this is the hash value that was computed by Webpack based on the actual specific contents of this file. And of course, the contents of this file is determined by your source code. And so if I change my source code and I ask Webpack to create a new bundle for me, because I've changed my source code, that means the contents of this is going to change, however small. But because the contents have changed, that now means that the hash value will have changed. So the hash value can be very useful to a browser from a caching point of view, because essentially, it's fairly obvious, I guess, but if the hash value part of the bundle file name hasn't changed since I last downloaded this particular bundle into the browser, then there's no need to download the bundle again. And that's what really caching is all about. Okay, I didn't expect to finish these slides, so that's fine. I'm going to halt it there and pick up the story probably on Tuesday with you, actually. But again, I'll kind of decide later on as to whether I'll finish these slides on Tuesday or the following Thursday. Right, so it's an incomplete lecture, but that's okay. Right, I'll leave it at that for today, and I'll talk to you next Tuesday. Thanks.
Thank you. Sorry, could I ask a question about the assignment?
Sure.
I was just wondering, the way that we have two repositories. So it's the GitLab and the GitHub one. Sorry, I think you're muted there.
Sorry.
No problem.
Go ahead.
Yeah, so we have the GitHub repository, and then there's the GitLab, and the GitLab is the one we had previously. It's already in there. So we're just going to have to add the GitHub one. Now, my question is, once we make changes to, like I'm starting off with the Cypress test, and I'm obviously going to be committing it to the GitHub one. Once I'm finished with the Cypress tests, and I'm going to move on to the GitLab for the pipeline tests, how is these changes going to be from put into place into the GitLab repository? Merged or?
Yeah. I kind of because Adrian, you did send me a Slack message yesterday, and that's what prompted my response into the general channel. Everybody has probably read that at this stage.
Oh, sorry, I didn't see it there.
Oh, did you not? I thought you.
No, I actually don't have the channel on my computer. I have it on my laptop, and I don't open my laptop just in college. So.
Oh, that's critical. I think what you I don't want to be not answering your question now, but
yeah.
If you look at that message that I put up yesterday,
yeah.
If you're still unsure, then by all means come back to me on Slack. But I tried to explain what how you should work, and essentially you kind of said that you could almost ignore GitHub in most cases. As in, by ignore, I simply mean you don't have to be pushing to GitHub on a regular basis. You should just think of GitLab, and as well, see, GitLab requires you to use a main branch rather than a master branch. So like initially, when you create a local Git repository, you have a master branch, okay?
Yeah.
Off of that master branch, you should have created a new branch called main.
Yeah.
Okay, so main is emanating from the master branch. And then from main, you would have created a branch called develop.
Mm-hmm.
And you'll be working between the develop branch and the main branch and your feature branches as well. Those three branches.
Yeah, that's for the GitLab.
Yeah.
But what's the GitHub then? What's
I know,
the point of GitHub?
So I'm coming to that now, right?
Oh, okay,
so
sorry, yeah.
If you think, let's say you're working away and you're creating a feature branch, doing some stuff, you merge the feature branch into your develop branch. you push, let's say, the develop branch to GitLab. You don't have to, but let's suppose you do, that's fine. Then you merge the develop branch into main. Maybe you push that to GitLab. You go back to your develop branch, create a new feature branch, and you keep on working that way. Now, notice I haven't mentioned the master branch at all. Okay.
Yeah.
Now, eventually, you want to bring the master branch in, and the only reason you want to bring the master branch into the equation is because of GitHub, and the only way that you will be using the master branch is by merging the main branch back into the master. And when you merge the main branch back into the master, you are effectively bringing in all of the stuff that you were doing between develop and the feature and main. All of that stuff now suddenly is hooked into the master branch.
Oh, okay.
Then you push the master branch to GitHub. And now suddenly GitHub has a history of everything that you were doing, even though when you were doing it, you weren't working with the master branch at all. You were just working with main and develop and the feature branch.
Okay, yeah. So it's kind of like a finalized product at the really end. They just pushed everything from the master branch from GitLab to the GitHub one.
Yeah. And I did say in that message on Slack yesterday is what I said was, when it comes to you wanting to satisfy the pull request part of the assignment specification, that's the only time you need to be working with the master branch.
Okay.
And I think I would advise people to only think about the pull request aspect of the assignment towards the very end, because it's essentially something that you're going to sit down with a classmate and you just do it there in the space of whatever 40 minutes. You'll get your classmate to submit a pull request to your project, and you submit a pull request to his or her project, and all of that will involve the master branch and GitHub. We're not concerned about pull requests in GitLab.
Okay.
Yeah, it's a bit complicated. I'd admit. Just see how you get on. Once you've read the Slack message,
Yeah, I will. Yeah,
see if it's clearer to you. And if it's not, there's no problem. I can tackle it on Monday. But my abbreviated answer is, don't worry about GitHub at all for now.
Okay, perfect. So I should just start off work using the kind of what we did in GitLab, this kind of workflow basically, with developing the Cypresses and then pushing them.
Correct.
Okay, perfect.
Yeah,
awesome.
Bring GitHub into the equation towards the back end.
Perfect. Thanks very much.
Great. Thanks for that. Bye.
Bye now.